Alright guys, before we get started here, I do have to give a shout out to Miguel 6th period. He's been my #1 fan since his YouTube channel came out, and again, he gets upset if I don't give him a shout out, so Miguel, this one's for you. Alright, so guys, you know the drill. Set up your Cornell notes. Make sure you guys copy that title, Solving Linear Systems by Substitution. This is again going to be day 3. We're going to get that extra practice in today. Make sure you guys copy that essential question, alright? And again, at any moment, if I say, hey, pause, make sure you do so. So we can pause it here, copy this down. All right, so here is our very first example. So make sure you guys copy this down. I'm going to go through this one with you guys. So follow along. It says solve the following. I have 3x plus y is equal to -3, and I have -2x plus y is equal to 7. Now again, I want to solve this by substitution. Remember, the very first thing is I have to get one of the variables by itself, either x or y, but I want to be smart about this so I don't do extra work. Now what I always like to do is, hey, if I take a look at each individual variable here, let's take a look at this x here. Well, there's a 3 in front of it. That's going to get messy. If I take a look at the y, hey, this is kind of nice. There's nothing in front of this, so this should be easy to solve for y. Let's take a look at the other ones though. Again, this x here has a -2. It might complicate things. I might get a fraction, so I want to avoid getting x by itself here. Hey, y, I can also use the second equation and get that y by itself. It should be pretty easy. Just move over a -2. Now again, I'm just going to pick here, let's say the first one, drop down my 3x plus y is equal to -3. Now again, I want to solve for one of these variables here. And again, I want to make my life easy, so I'm going to solve here for y. Well, how the heck do I do that? I have to get rid of this 3x. So I'm going to say, hey, -3x, -3x. These cancel out. I'm going to be left with y is equal to -3x -3. I can't combine them. One of them had an x, one of them doesn't. All right, so remember, that is step number 1. Solve for one of the variables. Here I've solved for y, and I figured out that y is equal to -3x -3. Now here comes the key part, or stage 2, which is the substitution piece. I need to take the value of y here, and I need to plug this in to the second one for the y variable. So all this is going to get plugged into the y here. Now again, if this was x equals, then I would have plugged it into the x. So my equation here is going to actually turn out to be -2x plus y. But instead of that y, I'm actually going to replace it with, and here in parentheses, -3x -3, change back the color here, is equal to 7. Okay, now all I have to do is I have to go through the steps here and then solve a multi-step problem. Now again, whenever you see parentheses, you always ask yourself, hey, how do I get rid of them? Well, let's distribute what's in front. Now it's not the -2x. No, be careful. There's actually this imaginary one sitting there that I distribute. So 1 times -3x is -3x. What's 1 times -3? Well, that's just going to be -3. Everything else has to come right back down. My equals 7, my -2x. Now step number 2 is always look, hey, can I combine anything? And actually in this case I can. I have -2x and -3x. They're on the same side, they both have a variable. -2, -3, that's going to give us -5. -5x -3 is equal to 7. Notice this just became a 2-step equation. How do I get rid of that -3? I say, hey, +3 to both sides. These guys cancel out. I'm going to be left with -5x is equal to 10. All right, now last thing I have to do here is I have to divide both sides by -5 divided by -5. These guys cancel out. I get x is equal to, what's 10 divided by -5? -2. You got to be careful. Now again, I keep reminding you guys, your solution, okay, this is actually going to be a 1 solution, but I don't just say x equals -2. It's something, comma, something, some x and some y value. Well, I figured out that x is -2. How the heck do I figure out what y is? Well, I have to take this x value and substitute it back to the original problem. Now, it doesn't matter which one you use, but make sure that because this is x, this -2 is x, you're going to have to plug that in either here for the right next to the 3 or right next to the -2. I'm just going to pick the first one. Why not? I have 3x plus y is equal to -3. Now again, be careful where you plug this back into. This is the x value, should go in the x spot. This is going to be 3 parentheses -2 plus y is equal to -3. What's 3 times -2? That's negative 6 plus y is equal to negative 3. How do I get rid of that minus 6? So I say, hey, plus 6 plus 6. These guys cancel out. Y is equal to negative 3 plus 6 is a positive 3. Hey, I figured out my x, I figured out my y. My solution is negative 2 comma 3. This would make both equations true at the same time. Now again, if I was to graph this, this is the point of intersection. This is a one solution. All right, so what I want you guys to do is take a look at the second example. All right, try it on your own. Pause the video here. When you're ready to go, check your answer. Make sure you hit resume. All right, I'll see you guys in a second. Alright guys, so what we're going to do here is same deal, solving by substitution. Now I have x minus 3y is equal to 9, and I have x plus 4y is equal to 2. Now in this case again, hey, what variable should I solve for? Now again, if I tried solving for the y's here, well, the negative 3 here is going to make it gross if I try solving for y. And if this y here, well, the 4 is in front of it. It's going to make my life complicated. The nice thing about it, hey, there's a 1 in front of this x, a 1 in front of this x. So I rather solve for the x. It's going to be so much quicker, so much easier. Now this time, again, I'm going to pick the first one here. I'm going to have x minus 3y is equal to 9. But this time, I'm not solving for y. I want to make this easy. All I have to do to get the x by itself is say, hey, if I do plus 3y to this side, I do it to the other side, keep it balanced, these guys cancel out. Well, x is equal to 3y plus 9. Well, I've solved for the variable again. Where's this gonna go now? Well, this has to go into the one that I didn't use, but it's gonna go in for the x spot. So I'm not gonna go for the y, I'm actually gonna substitute in here for the x. My equation should look like, I'm gonna put this in parentheses. This is gonna be 3y, because I'm replacing that x, plus 9. And now here, let me change the color. This is going to be plus 4y is equal to 2. Now again, I have parentheses. What's in front here that I can distribute to get rid of them? Well, there's that imaginary 1. And again, all this is really doing when you distribute by 1, it just gets rid of the parentheses. But again, you just want to make it a habit. Because again, it won't always just be a 1. It might be a 2, a 3, or 4, whatever. Everything else is being brought down here. Now again, ask yourself at this point, hey, is there anything that I can combine? Okay, there is. I have a 3y and a 4y on the same side. 3y and 4y are going to give us 7y. Let me drop down my plus 9 is equal to 2. Hey, this just became a two-step equation. All right, how do we get rid of that 9? I say, hey, opposite of plus 9 is minus 9. Inverse operations here. These guys cancel out. I have 7y is equal to, what the heck is 2 minus 9? Be careful there. That's actually going to be a negative 7. Now, how do I get rid of the 7 in front? While multiplying, the opposite of multiplying by a 7 is to divide by a 7. So I get y is equal to, these of course canceled out here to give me 1y. Negative 7 divided by 7 is going to give us a negative 1. Now, if we remember, I told you guys, hey, that's not our final answer. As soon as I get to x equals something, y equals something, I know I'm going to have a one solution type of problem, but my solution should be some x comma y. Well, which one did I figure out first this time? I actually figured out the y. This should go in the second spot. This is negative 1 for the y value. Now, how am I going to get the x? Very similar to the last one. Here, I'm going to take the y value and plug it back into the original problem. Now, again, I don't want to plug it in for x. That's not x. That's y. So I'm either going to plug it in here or in here. This time I will pick, let's pick the second one. Looks like I have smaller numbers here. I don't want to deal with that 9 and that minus sign. Again, would it matter? No, you should still get the same answer. So I have x plus 4y is equal to 2. Now again, this was the y value. Make sure it gets substituted in for y. So I have x plus 4 times negative 1 is equal to 2. Well, what's 4 times negative 1? That's just going to be negative 4. Is equal to 2. How do I get rid of that minus 4? I say, hey, plus 4 to both sides here. Cancels out. I get x is equal to, x is equal to 2 plus 4, which is 6. Okay, that's my x value. I figured out my solution is at 6 comma negative 1. If I was to graph these again, they would cross at 6 comma negative 1. This would make both equations, if you actually went in and plugged it in and you checked it, it makes both of them true. You'd get 9 equals 9, and you'd get 2 equals 2. All right. Last one here, guys. What I want you to do is, again, same deal. Try to solve this one on your own. Okay, when you're ready to go, hit resume. We'll go through it together. All right, so here we have example 3. So again, now I have 3x plus y is equal to 14. I have 2x minus 6y is equal to negative 24. All right, let's be careful here. Which variable should I solve for? Now again, if I take a look at the bottom one here, well, if I solve for y, there's a negative 6. It's going to complicate my life. I might get a fraction. Same thing with this x. There's a number in front of it. That might not be the ones I want to use. If I take a look at the x up here, well, there's a 3. It's going to mess it up. I could, but I don't want to deal with fractions, right? I want to work smarter, not harder. Now, if I take a look at the y here, hey, there's a 1. This should be a quick fix. If I want to get that y by itself, all right, shouldn't take that much work. All I have to do, okay, is kick over that 3x. It's just going to become a negative 3x. I say minus 3x, minus 3x. I get y is equal to negative 3x plus 14. Hey, I've solved for y here. I know y is equal to all of this information here. Now this is the substitution step. Now again, if I use the first one, I can't use it again. I have to make sure that I plug this in for the y value, not the x, but the y. All of this is going to go in for y. So my new equation should be here. 2x is still the same. Minus the 6. But instead of that y, what am I going to replace it with? All of this, I want to make sure I put it in parentheses. Negative 3x plus 14. So in a different color here so you guys see it, that I'm actually picking it up and dropping it in for the y, is equal to negative 24. All right, well, let's go through this. Again, I see parentheses. What's in front here? I can distribute the negative 6. All right, so negative 6 times negative 3, that's going to give us a positive 18x. Now, what's negative 6 times 14? Well, that's a negative 14 times 6. Let me do it up here. Let's see. That's going to be 24. Bring the 2 over. 6 times 1 is 6 plus 2 is 84. That's going to give me a negative 84. Bring down everything else real quick. The 2x. Okay, again, what do we do once we distribute? Ask yourself, can I combine anything? Is anything I can collect? Here we have 2x and 18x, which give us 20x. Minus the 84 is equal to negative 24. Now, two-step equation here. I want to make sure that I add 84 to both sides. Add 84. I get 20x is equal to 60. If I divide both sides here by 20, I get x is equal to 3. Same thing, guys. We're not done. It's quite a bit of work. Yes, I agree. But again, once you get in the habit, these start going by pretty fast. My solution is, well, x is equal to 3. The way I find y is I have to take this and I plug it in. Doesn't matter. I'm choose the easier one here this time. Right? I don't want to deal with negative 24. So I have 3x plus y is equal to 14. If this is the x value, it better go in the x spot. 3 parentheses 3 plus y is equal to 14. What's 3 times 3? That is 9. 9 plus what is going to give us 14? Okay, that's, some of you guys can already see it. That's going to be 5. If I subtract 9 from both sides, I get y is equal to 5. My solution is 3 comma 5. Again, that is the point of intersection. It's a one solution. All right, guys. So I'm gonna skip this for a second. Don't forget though. I want to keep this video short. Don't forget to write your reflection. You can actually pause it right here and take a look. This could be an example of what you would kind of talk about in your summaries. All right. So here is your class activity. All right. For number 7 and number 8, it's exactly what we just finished doing. Okay. So go through it. For number 9, it says, hey, fill in the rest of the table. So again, if I give you all the x's, how do we get the f of x, or in other words, the y? Take your x and you substitute. Take your x and you substitute. We've gone through this. Write the equation for the graph. So again, you want to write it in y equals mx plus b. This might be easiest. Work backwards. What's the y-intercept? Somewhere down here. Be careful, they go by 2's. What is your slope? What is your rise over your run? Okay, last one here. Using the x-y-intercepts. Remember, that's when you set x equal to 0, and that's when you set y equal to 0. Once you have those x and y intercepts, make sure, don't forget to graph it. All right, guys, make sure you get this done. Have a nice day. I will see you guys tomorrow.